Now let's say you had something from, I don't know, Honka. You know, the set of atoms that are always not by themselves. If they are by themselves, they're in just twos, like oxygen. Oxygen is always in a pair of two, O2. So, how do you calculate the molar mass for those? Well, it's really quite simple. All you have to do is multiply by that little number at the bottom right, which is, in this case, 2. So, you take the molar mass, rounded to 4 significant digits, which is 16, and multiply by 2, which ends up to be 32. Now, just like units, you gotta remember your significant digits all the time, or else, you know, stuff. Meanwhile, while I already have nuked 2 things, I don't think I really have had the chance to explain why we need the mole in the chemistry class, if anywhere else. Let's take a look at my notes, shall we? Oh, well, don't mind the doodles. I tried my best to draw around them. Here, I'll circle the important stuff for you. That's the wrong stuff. There we go. More often than not, you'll receive something in a unit other than moles, like grams, or formula units, or molecules, or atoms, etc. You follow this chart to find out your way to the mole. It's like a road, and you only have one path, so don't worry. You're not going off at exit 29 to get to the Delaware village. That was totally made up. So, yeah, know it well. You'll be using it a lot. Trust me. I've done a total of 3 problems. Okay, maybe a little more than that. But maybe 3 problems that are right. But don't worry, I've improved. However, before I go on, there's one exception. If you are converting from volume to moles, it can only be done in 22.4 liters if it is at STP, or standard temperature and pressure, which is 0 degrees Celsius, and I'm not so sure about the pressure part actually. But usually it'll tell you. And if it doesn't tell you, and you don't know if it's at STP, well, then you can doodle something or something, unless you know the solution. So, yeah, doodle a dragon. Rock on! Back to the notes, which are actually pretty horrible to look at. 1 second as I use magic fingers to change these notes into something a lot nicer to look at. I am so magical. Anyway, you may be wondering why there are now 2 moles in these notes. How horrible! Twice the... Actually, no. It's actually not twice the amount of equations to memorize in your head. It's actually just what you were trying to memorize plus 1. You see that box thing in the center? That would be the mole ratio or mole conversion factor, which will also be used a lot later. I'll get into that if this night lasts long enough for me to procrastinate through to get to it. But for now, onwards with the original stuff. Wait, what was the original stuff? Oh yeah, now I remember. There you go. I shrunk down the notes for you. But we won't see them for long because it's time for examples. Yay! So as what I'm expecting is a bad example that I made up at the top of my head, let's just say we have 2.5 grams of H2o and 36 liters of chlorine. How do we put that into moles? Easy. Let's start with chlorine. Okay, so let's just say I took the chlorine to a highly specialized lab that makes everything at STP through magical fairies. Now I only have one step, and that is to convert to moles using 22.4 liters as a conversion factor. Actually, this might be a good time to mention every single equation you do must be in conversion factor form, or else or at least that'll happen in your grade. Anyway, you see the solution. The key is to cancel out each unit until you get what you're looking for. Liters of chlorine 2 cancel out because I used the conversion factor from volume to moles, which basically is dividing chlorine 2 by chlorine 2 to get moles of chlorine 2. Hopefully that makes sense, because it didn't really make sense coming out of my mouth. Anyway, you also saw that there are a lot more numbers than 2 in the calculator. Well, you start with 2 significant digits, you end with 2 significant digits. I'm not sure I need to show the nuclear explosion I showed you when you don't use significant digits. Yeah, you see, that's what's on the line here. Some nuclear explosions might go off if you don't use them, so use them, okay? I'm glad we're clear on that. Let's move on to the first example I gave, 2.5 grams of H2o. This one is a little different because H2O has 2 elements, hydrogen and oxygen. All you really have to do is take those elements, those 2 elements, molar masses, and multiply them by however much there is in the problem, or the molecule. So in this case, 2 hydrogen molecules, or elements, and 1 oxygen. Take the molar masses and multiply them retrospectively. And so you get 2.02 grams of hydrogen per mole and 16.00 grams per mole of oxygen, because that's how much there is. Add them together and you get the molar mass for H2O. Now all you have to do is divide it into your original mass, which is 2.5 grams. Divide them together and you get your magical answer. Yay! But if this is hard, I'm not exactly sure what to say. I either suck at teaching, or I must say sorry, but your chemistry just might not be your strong point. And so my procrastination time is up. So I shall leave you with one question and one pop quiz, because the question is your pop quiz. What is the value of 1 mole?
It's over 9,000!
And so with the little information I gave you, I bid you good luck and adieu. For this will never continue unless someone really wants me to.